Let's look at another example in 8.4. Let's look at number 20. The following data are based on information from the Regis University Psychology Department. In an effort to determine if rats perform certain tasks more quickly if offered larger rewards, the following experiment was performed. On day 1, a group of 3 rats was given a reward of 1 pellet each time they ran a maze. A second group of 3 rats was given a reward of 5 pellets each time they ran the maze. On day 2, the groups were reversed. So the first group now got 5 pellets for running the maze, and the second group got only 1 pellet for running the maze. The average times in seconds for each rat to run the maze 30 times was shown in the following table. Okay, so my first row here is the ones who got 1 pellet. The second row is the ones who got 5 pellets. So I will put in my calculator the first row in L1, the second row in L2, and I'm just consistent at doing that. There are different ways you can do this, but I think it becomes confusing. So because I'm putting this in L1, here's 1 pellet, L2 is 5 pellets. Okay, so when I set up the null and alternative now, you know the null is going to be mu d equals 0. To determine what the alternative is, I read the question. Do these data indicate that rats receiving larger rewards, so these are getting larger rewards, right? 5 pellets versus 1. So I want to know if these run the maze in less time. So I want to test if this one, this group, is smaller than this group. This is why I write them right beside each other. So I'm testing if this one is smaller. So I want to point to the smaller one, right? So I'm really testing if the rats with 1 pellet have a larger time than the rats with 5 pellets. Does that make sense? I want to know if this one, the rats receiving larger rewards, run the maze in less time. I want to know if this one's smaller. So if I write this way, then I know my alternative is going to be, I'm testing if it's greater than 0. Make sense? You have to be careful with these. So when I put them in my calculator, I'm putting my first row in the first column, my second row in the second column. So to do these matched pairs, remember you go up to L3, you're going to type a formula, L1, which is above the 1 key, minus L2, which is above the 2 key. And that created my L3 column. Remember to do our test statistic on these. I'm doing a t-test on L3. So I do second quiz, stat, test, t-test. Choose data. My mu naught's always 0. I'm always on L3 on these. This time my alternative is greater than. And calculate. So my t-test statistic is 2.19. Go ahead and write down my p-value while I'm at it. 0.0400. Draw our critical region for step 3. This is a right-tailed test. Degrees of freedom is 6 minus 1. There were 6 groups, or 5. Go to my table. This time go to one-tailed test. Go over to 0.05. Down to 5. Looks like 2.015. Okay. So then I draw in my test statistic, 2.19. This is going to be a close one again. Does this come on this side of 2.015 or the right side? It's going to be a little bit larger, right? So this time it does fall in my rejection region. So I'm going to reject H naught. Down here with my p-value, same statement as always. I'm going to reject H naught if p-value is less than alpha. My p-value is 0.0400. My question is that less than 0.05? Because I look at them as both numbers. Is 400 less than 500? Absolutely. Yes. Since I said yes, I reject H naught. Are these the same? Check, check. You with me? Step 5, at the 5% level of significance, we want to say we do or do not have enough statistical evidence. The only time we say do not is if we do not reject. So this time we do have enough statistical evidence to conclude that rats receiving, I look for that in my problem, do these data indicate that rats receiving larger rewards tend to run the maze in less time. So we do have enough statistical evidence to conclude our alternative, that giving them larger rewards helps them run the maze in less time.